Alright, hello once again, Jeff Scott of Rankin Technical College. We've been going over the PowerPoints and writing some code for Farrell's Microsoft Visual C# 2015 and Introduction to Object-Oriented Programming. And on the PowerPoints, I've got 2 chapters left, so I'm on Chapter 13 of 14 right now. And hopefully you can see that the chapter is on event handling. So in this chapter we learn about event handling, we learn about events, we learn how to declare our own events in handlers and use the built-in event handlers. We learn how to handle control component events, mouse and keyboard events, how to manage multiple controls, and how to learn how to continue on in our journey to find out about this stuff. So most programming languages are event driven. So in other words, you can kind of look at it as though the program, the software is sitting there waiting for something to happen. It wants to react, as the author says here, to an occurrence of some kind of a program event. Alright? Actions that occur while the program is executing are known as runtime events. So, an event drives the program to perform a task. You already know what this is because almost since the first chapter, we've been writing, for example, GUI programs that have a button that when you press the calculate button, some kind of a calculation takes place. When you press a clear button, all right, one or more text boxes are cleared, and maybe a list box or something else. When you press an exit button, the program exits. So as it mentions, events can be raised, fired, or triggered. And literally, you can write code for all sorts of events, but the thing is, most people just write code for pretty much the default events. And that code that you write to handle an event is referred to as an event handler. So as it says, an event handler is a method that performs some kind of task in response to an event. Alright, so here's an example when you work with a button. And you probably have seen this before. We may or may not have talked about it before. But there's the button for changing the label. So you click change label and hello becomes goodbye. And you'll notice that that change button gets passed an object that's called sender and event arguments that's called E. As it says, the event handler has an event receiver and it has what's called an event sender. So the sender basically is who sent the event. It's you basically because you clicked it. Args, most of the time, args is going to be empty because it's an array of arguments. But for instance, if you were writing a program that was working on a game, then you might have arguments. They might pass an X and a Y coordinate to make sure that when you're shooting at a spaceship or whatever, that you're hitting it. So when you double click on the button, by default, it displays the button's click event. You've seen this before. So again, the event handler displays the sender's information. So if we put that in sender.toString, it would tell us that basically this has been generated by the form and the button on the form. The E object, as it says right here, okay, it says the user used the mouse to click the button. So that's what it's telling us. Click events, as mentioned here, are fired when a user clicks a button during program execution. Event wiring says connecting an event to its resulting action. So in other words, what event wiring does is it's the code that fires in response to some kind of an event on your part. And so far we've only talked about click events, but there are other ones as well. Alright, let's jump into a little bit different subject, and that's the subject of delegates. As it says, a delegate is an object that contains a reference to a method. Remember, when you're working with references, you're working with addresses, memory addresses. So a delegate, as it says here, encapsulates a method. It provides a way for a program to take alternative courses of action while it's running. As an example, and this is not really an example of a delegate per se, but let's just talk about it. Let's say you were writing some kind of an application for a 4-year school, all right? And you might want, let's say that you had all 4 grades, freshman, sophomore, junior, and senior, taking a test. You might grade the test differently if it was a freshman taking the test as opposed to a sophomore taking the test, as opposed to a junior taking the test, as opposed to a senior taking the test. So as mentioned here, you can pass a delegate to a method which can tell or call the method referenced within that delegate. You declare it using the keyword delegate. This is about as hard as it gets in this book because it's different. All right, so what do we have in here? All right, notice we've got a method that's called hello, and it writes hello on the screen. And whatever we pass in for that string. So if I pass Jeff in there, it would say hello, Jeff. Same thing with goodbye. And we've got this greeting method. So we say greeting delegate, first del, second del. First del equals new greeting delegate, hello. Second del equals new greeting delegate, goodbye. So what it means is this greeting delegate, all right, can, since there's 2 copies of it, so to speak, it can hold, when we call greet method down here, it can hold either, right here, first del means that, oh, what we want to do is we want to call the hello method, and we want to pass it Kathy, so it should say hello Kathy, and it does. The second one says we want to call the second delegate, which is goodbye, we want to pass it Bob. So it says goodbye Bob. So in other words, from this code that's right down here with greet method, we can call one of 2 different methods right here. This will call one of 2 different methods depending upon the delegate that was passed in. So it gives us a little bit more power in our programs. You can assign one delegate to the other using the equal operator. Remember, it's not equals, it's assignment. You can use the plus and the plus equal operators to combine delegates into what's referred to as a composed delegate. And as it says, if you combine 2 delegates, it calls the delegates from which it was built, so it will call both. So in this case, we say first del plus equals second del. So when we do this, the greeting is, we should be saying both in here in one call. We should be saying both. The greeting is hello Kathy, the greeting is goodbye Bob. The greeting is hello Kathy, the greeting is goodbye Bob. All right, so you can see exactly what we're doing right here. All right, declaring your own events and handlers using the built-in event handlers. So what you can do is to declare your own events using a delegate. And as mentioned here, this provides a way for the class's clients to dictate what should happen when an event occurs. So if you want something special to happen, all right, you can do that. So if we take a look at the example right here, we've got this student class. It has 2 fields, and it generates an event when the data in either field changes. And as you can see here, when we look at the code that's right here that's in gray, it defines a third attribute, an event name changed. All right, so that changed event is only going to fire when we change something in the ID or we change something in the GPA. So for instance, the other day when I was taking attendance, there was a student that was absent. And when I went through and recorded all the people who were there and absent, I accidentally put the wrong student down as being absent. So later I've realized that, and I went back and changed it. That's when something like this would fire. The DOT framework, as mentioned there, provides guidelines to follow, when you're developing a class you want others to see. In other words, if you're developing your own class, for lack of better verbiage, there's kind of a way, a blueprint in which this is done. All right? And you really should follow the blueprint, because you shouldn't spring surprises on people who are trying to use your code. Otherwise, chances are pretty good they won't want to use it. What does that do? It indicates the delegate type for an event, meaning the source and the arguments. Notice again, defined by the .NET framework for events that do not use additional information. So what we're talking about doing here again is building in our own events. Now, one thing, and I didn't know whether to show you this now or not, because I'm not going to write any code, but I do want to show you something here. And we may have looked at this before, we may not have. All right, I'm going to bring up this exception handling program in here. The program that we're bringing up here is irrelevant, but I just want to show you something here. And that is, I'm going to bring the form up, okay? And we're used to, okay, there's our calculate button. And if we go down to our properties, we can see when we look what our different properties are. That's nothing new. The other thing that we can do if we want to is we can click this lightning bolt, and that shows us all of the different events that occur on this button for which, if we want to, we can put code. You'll notice that one of them has got something there and it's bolded. If we click that, that brings up the actual code that we've written. All right, but if we wanted to, so there's a click event. If I wanted to do something on a double click event, I guess there isn't one here for a button, but if I wanted to do something on some kind of a, I don't know, an enter event, all right, if I double click that, that would open up the code window, and down here it would say private void button calculate underscore enter, and then any parameters. So all I'm trying to tell you is this, and that is the fact that whether you realize it or not, typically we only write code for buttons and maybe if typically just for default events of these things. If I double clicked here, it would bring up the change event. Why is that important? Well, let's suppose right there that instead of, well, this one will work. It's got their entering number. Okay, I literally could set it up that if I came in here and I wrote code, I could set it up so the only thing that this would accept would be numbers. And if I tried to put in something non-numeric right here, it just wouldn't accept it. That might be a better way of actually writing code than the way I've written it thus far. Whoops, 13. All right. Like I said, there's no way that we can go through this stuff and that you will become an expert on it without you also reading the book. It's of paramount importance that you do that. All right, so existing controls have events with names. I just showed you some of them. Some of these events we've looked at. Some of these we haven't. Most of the ones I just showed you, enter for example, and click is the one we use quite often. If you're working with a mouse, you might be using key down and key press events. So if you're writing your own game, mouse enter, mouse leave, etc. So there's a lot of different things for which, if desired, you can write code. All right, scared there that says 45 seconds. All right, a form, as it says, may contain any number of controls, and any of those controls can have code associated with them. So you can add code to anything. There's a mouse enter event. So notice that when our mouse goes on the click me button, so when we just put our mouse there, what happens is this label will become red and its text will be changed from go ahead to button was clicked. All right. Mouse events, as mentioned, are one of the ones that are the most popular. I have to check this, and I have to check my time on here. Okay, I'm fine. Well, the program's fine. I don't know about me. So, mouse events and keyboard events they handle things that happen with a mouse or things that happen with a keyboard. Here are some of the major mouse events. Again, these don't make any sense until you start writing some code. There was a game, and I'm sure it's out there someplace, that was very popular a while back. And what it was you had like a little smiley face that when the program started was right in the middle of your screen. And the idea was what you wanted to do was you wanted to take your mouse and click on that smiley face. That's how you won the game. But as soon as your mouse got close to that smiley face, it moved to another spot on the screen. And the spot it moved to on the screen was some kind of a random spot. It would move to another corner, another end, or both. All right? And that was supposed to be a fun game, and it was very hard to win the game if you played it fairly. The X and Y coordinates are basically exactly where you are on the screen. So here's an example. So if I click there, I'm at 198.204. If I click there, I'm at 218.156, etc. And the X coordinate is where you are on the X-axis. The Y coordinate is where you are on the Y-axis. And 0, 0, the point of origin, is not in the middle. It's in the upper left-hand corner. And that's the way it works in computers, period. Not only can you handle mouse events, you can handle keyboard events. All right? So you can handle when the key is pressed, when it's released, when an Alt key is pressed, when a Control key is pressed, when a Shift key is pressed. You can get the arithmetic code for the key that you pressed, the ASCII character. So there's a lot of different things that you can do here. So the author in this chapter, Good, Bad, or Indifferent, writes a lot of examples where you can come in and you can run these and just to see exactly what's happening. All right. We've looked at the focus event. I've set the focus event throughout the semester, and the tab index event. All right, I've never worked with tab stop myself, but you can see what that is right there. So if we want to set focus, it's the dot focus event. There are literally, as it says, hundreds of different controls. And one thing to realize, if we were to go back to our code here, I showed you everything that was in there. These are the events. Let's say there's 20 or 30. I don't know. I don't care. All right. But you'll notice it starts with accepts, tab change, back color changed, etc. If I go over to here, and if I click on the button, it changes. So those are our button events. If I were to put a label, click on label, that's got its own events. Many of these events are the same throughout different types of controls, regardless of the control type. And some are different, they're unique to that particular control type that you're working with. So in this chapter, this was very much an exploratory chapter, a general chapter. We looked at a very important topic of event handling, a very important topic of delegates, and we looked at some common control events, mouse events, keyboard events.